Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, I want to show you how to find the factors of numbers so that we can find the GCF or the LCM of multiple of numbers. So, when we talk about divisibility, we can find, whether a number is divisible by 2 or 3 or 4 or 5, but generally speaking, we only care about prime numbers. So we need to find the prime factors of any number. Prime meaning a number that is only divisible by itself or by 1, of course. Okay? If it's divisible by something else, it's no longer uh, a prime. We call it a composite. But a prime numbers would be like 2, 3, 5, 7, 11. So you notice with after the 3, all of them are odd numbers, okay? And so on and so forth. So when I have a problem where I have to factor something out, or if I have fractions and I want to take a common denominator, I need to know the numbers in the denominators, uh, if they were divisible by any one of these, so that I can find the LCM. Okay? So you already know that a number is divisible by 2, so that's an easy one. Divisibility by 2. The number ends with an even digit. So the ones digit or the units is either 0, 2, 4, 6, and 8. And pretty much I guarantee everybody knows that. So we didn't need to waste time on it. Same thing with 3, probably. If not all, then 99% of you know divisibility by 3. If the sum of digits is divisible by 3. So let's take an example of an even number. It doesn't matter how many digits. So I can say 418 is divisible by 2 because it ends with an even number. So it doesn't matter how many digits the number has. Divisibility by 3, same thing. You can have, for example, 291. When I add the digits, I get 12. And since the 12 is divisible by 3, then 291 is divisible by 3. Okay? Of course, you can do the 4 if you wanted, but 4 is not a prime number. But if for any reason you want to find divisibility by 4, it's so easy. Multiply the tens digit by 2, then add it to the ones digit. Again, if the sum is divisible by 4, then the number is. Very simple one is, for example, let's say, what about 52? I multiply 5 by 2, I get 10, plus 2 is 12, and since 12 is divisible by 4, then 52 is divisible by 4. You already know that because you have 52 playing cards in 4 suits of 13 cards each, right? So it's 13 times 4. 5 is even easier. You already know that. Any number any number that ends with 0 or 5 is divisible by 5. And you know how to divide any number by 5? Of course you know, but maybe there is a shortcut. For example, let's say I have A number, you know it's divisible by 5, but you really don't want to do the long division or something. Like, for example, if I tell you 135, I know it's divisible by 5 because it's end with 5. Okay, some people will say, okay, let's split it into 135. Yeah, you can do that. Another easy way is just to add it to itself, meaning multiply it by 2. Add it to itself and then cross out the 0 on the right. So 5 plus 5 is 10, 0, and you carry over 1 plus 3 is 4 plus 3 is 7, and 1 plus 1 is 2. You come here because what we did here is we divided by 2. I'm sorry, we multiplied by 2, then divided by 10. It's the same as dividing by 5. But sometimes it's easier if you don't want to waste time. Okay? 135 plus 135 is 270, so the answer is 27. 135 divided by 5 is 27. Okay, how about, let's say, divisibility by 6? Any number that is both divisible by 2 or 3. So the first thing I look at has, number 1, has to be even. If it's odd, I stop. I don't waste my time. Has to be even. That's number 1. And then number 2, its digits or the sum of its digits. I was going to say will add up. Well, sum of its digits is divisible by 3. So that guarantees that it's divisible by 3, even guarantees that it's divisible by 2. So definitely it's divisible by 2 times 3 or 6. For example, let's take something. Let's take, for example, 216. It ends with an even number, so I can continue. Its digits add up to 9, and 9 is divisible by 3. Then this number is divisible by 3. Okay? It's 36 times 3 times 6. This is really 6 cubed. Okay, let's move to another one. Let's say divisibility by 7. Now, notice we did the 2, we did the 3, we did the 5, and now we are going to do the 7, along with some other numbers that are not prime. For the divisibility by 7, divide your number into two pieces, the units, the ones digit by itself, and the rest by themselves. So for example, let's say if I have 315, the first thing I do, I split it like that. Only the ones digit by itself and the remainder of the numbers, the remainder or the rest of the number by itself. You double that, so you get 10. And then you look at the difference between 31 and 10. 31 minus 10 is 21. And since 21 is divisible by 7, then 315 is divisible by 7. So I take the ones digit by itself, multiply it by 2, and then either subtract it from or subtract the rest from it, depending on which one is larger. Most of the time, the rest would be larger, but you never know. If I say 14, of course, nobody will check that. But 4 times 2 is 8, and 8 minus 1 is 7, divisible by 7. So you see, it's so easy. 8 is also easy because basically, okay, let me show you how you do 8. Let's pick again. I keep doing the cube. I don't know why. So let me take something else. So let me say 552. Okay. Remember here what we did? When we said divisible by 4, I only care about the last two digits. So for example, okay, so I'm going back going back to the 4. For example, suppose I have 3,924. I'm going to take the last two digits. That's all what I care about. You can say 24 is divisible by 4, so you're done. But if that number wasn't easy for you, for example, it was like 68 and you're not sure, you take the tens digit. We said multiply the tens digit by 2, it becomes 4, and then you add to it the ones digit. 4 plus 4 is 8. 8 is divisible by 4, so 3,924 is divisible by 4. Okay? So it's so before we say it's even, if it's 2, we say if it's even or not. If it's 4, first you multiply this by 2, you add it, and then you see if the sum is divisible by 4. For divisible by 8, I'm going to multiply this by 1. Notice I multiply the 4 by 1 and the 2 by 2. And I got 4 plus 4 is 8, so it's divisible. Here, I'm going to multiply that by 1 and this by 2 and this not by 3, by 4. Why by 4? I multiply by another 2. It's like 2 and then 2 square. If I want divisibility by 16, I will multiply the next one by 2 cubed, which is 8, but nobody will check higher than that, right? So 2 times 1 is 2, plus 5 times 2 is 10, plus 5 times 4 is 20. 20 plus 10, 30 plus 2 is 32. And since 32 is divisible by 8, then this number is divisible by 8. So if it's 2, it's like you multiply the ones digit by 1, meaning itself. So I multiply 8 by 1, it's 8. And since 8 is even, then it's divisible by 2. When it's 4, you multiply the ones digit by 1, the tens by 2. If you want to check for 8, you multiply this by 1 and this by 2 and this by 4. Okay, if the sum is divisible by 8, you do that. If you want to check by 16, you would multiply the first by 1, the second by 2, the third by 4, the fourth by 8. You add them up. If the sum is divisible by 16, then the number is divisible by 16. Divisibility by 9. Easy. Exactly like 3. Sum of the digits is divisible by 9. 400 and this is what? 78? No, 77. 477. 4 plus 7 is 11 plus 7 is 18. And since 18 is divisible by 9, then this number is divisible by 9. Of course, divisibility by 10, meaning the last digit is 0, right? This is very simple. Like the 5, but we say only ends with 0, not 0 or 5. If it's 0 or 5, it's divisible by 5. But if it's only 0, then it's divisible by both 5 and 10. So we are not going to write that. And finally, I'm going to stop here, divisibility by 11. And then maybe in another session, I will tell you if you want divisibility by any number, what is the, I won't call it tedious way, but it's a guaranteed one, but it's maybe lengthy. It depends on how many digits you have that you are checking. Okay, divisibility by 11. Let's write some large numbers. So I'm going to say 7, 1, 4, 9, 6, let's see, 7. And I tell you this number is divisible by 11. How did I know? Yeah, I made it up. How did you make it up? I took the first digit, I added it to the third digit, I added that to the fifth digit, and if there was a seventh digit, I will also add it up. So I add the oddly placed numbers, the first, the third, the fifth, the seventh, and so on and so forth. 7 plus 4 is 11, plus 6 is 17. Then I add the evenly placed number, this one, plus that, plus that. I get 1 plus 9 is 10 plus 7 is also 17. If they are the same, or they differ by a multiple of 11. So if I add those, for example, it's impossible, but let's say I got 28. I cannot get 28 with only three digits because 9 plus 9 plus 9, which is the highest, is 27. But I'm saying, let's say I kept adding numbers and I ended up with the top being, for example, 17 and the bottom 28. The difference is 11, so the original number would be divisible by 11. So either equal or differ by multiples of 11. Like, for example, let me show you 715. 7 plus 5 is 12, and there is only a single digit that is second. There is no fourth, right? 1. The difference between 12 and 1 is 11. So this number is divisible by 11. In fact, it's 65 times 11. I hope this was clear. That would help you find out, uh, to factor numbers or to find the least common multiple if you are dealing with fractions. And in the next session, maybe, or in another session, I will show you how to use that and find a least common multiple of several denominators in order to have a common denominator and be able to add or subtract your fractions. Okay? I hope this was clear enough for you. If you have any questions, as usual, please drop me a line in the comment section and I will get back to you as soon as I can. Thank you very much for watching and have a great day.